Today, I speak about the circulating microRNAs as a promises biomarkers for monitoring of NLSD-M clinical phenotype. MicroRNA are small single-strand non-coding RNAs that regulate gene expression at the post-transcriptional level. MicroRNA are involved in several pathological and physiological processes, such as development, proliferation, differentiation, and cell death. Some mRNA are tissue-specific, while others are expressed in multiple tissues. There is evidence that microRNA are also present in a biological fluid, such as serum, plasma, and saliva. Alteration of circulating microRNA have been documented in several muscular dystrophy and other clinical conditions, such as obesity and insulin resistance. Therefore, they could be used as biomarkers of progression in neuromuscular and metabolic disorder. In this study, we analyzed two different groups of mRNA in serum. Canonical muscle-specific microRNA, called MyomiRNA, are MIR1, MIR206, and MIR133A and B. MIR1 and MIR206 promote myogenic differentiation, while MIR133A and B maintain the undifferentiated state and promote cell growth. Another group of mRNA that we can take into consideration in this study is mRNA with important function in lipid metabolism, fatty acid oxidation, and lipoprotein, such as MIR378 that was involved in mitochondrial metabolism and glucose homeostasis. MIR27A that regulate lipid metabolism in the liver, MIR33A with an important role in inhibiting fatty browning formation and with a role in hepatosteatosis. MIR122 that is the first mRNA described involved in lipid metabolism, regulate fatty acid oxidation and cholesterol synthesis. MIR155 is a classical described as a mRNA involved in inflammation and immune response, but it has an important role in liver pathologies and arteriosclerosis. And natural lipid storage disease with myopathy is a rare autosomal recessive disorder of triglyceride metabolism. To date, about 100 patients have been described. The patients are mainly affected by progressive myopathies. About 45% of patients have cardiomyopathies, hepatomegaly, and other hepatic enzymes. Other clinical symptoms are diabetes, hearing loss, chronic pancreatitis, and short stature. This pathology is characterized by an abnormal accumulation of triglyceride into cytoplasmic lipid droplets due to a mutation in PNPL gene, which codes for ATGL. This lipase is the major responsible of lipolysis and catalyzes the first step in the hydrolysis of triglycerol. The abnormal accumulation of lipid droplets is present in many different tissues. Here, we show two pictures. In the first, we can observe the accumulation of lipids that occur at the leukocyte level, called Jordan's anomaly. Well, in the figure 2, already those 10 muscle biopsies reveal massive lipid droplets storage. Actually, for this pathology, there is no specific therapy. The pathogenetic mechanism leading to muscle damage are unknown, and MyomiRNA and the microRNA involved in lipid metabolism has never been studied in these pathologies. The aim of this study is to investigate the expression profile of circulating serum microRNAs in NLSD-M and evaluate their role as biomarkers in disease evolution. We studied three affected subjects from an Italian family with NLSDM with two heterozygous ATGL mutation, in which the severity of clinical features were highly variable. Two male brothers aged 51 and 15 present an asymmetric distal myopathies. While the sister, a woman of 58 years old, had hepatosteatosis and diabetes. All patients have high CK level and high level of hepatocyte enzyme. Here we show the muscle imaging and muscle biopsies. CT scan of patient 1 shows severe adipose tissue substitution in posterior thigh and leg. MRI imaging of the patient 3 reveal a relative preservation of deltoid muscles with asterisk, and a slight fibrofatty infiltration in adductor magnus and semimembranosus. In posterior leg, fatty infiltration is more marked than in anterior leg, and only in tibialis posterior and soleus muscles are spared. In muscle biopsies, lipid droplets were observed. In this study, we studied the circulating microRNAs in your NLSD-M patient compared with healthy subjects. The bar graph shows an upregulation of MyomiRNA in our patient. In particular, we show an upregulation of MYR206 that was about 13 to 14 higher than in controls. MYR133A was about 5 to 9-fold higher than in control groups. MYR1 and MYR133B was elevated in P1 and P2. We also investigate the expression level of circulating microRNAs involved in lipid metabolism. The figure shows a significant upregulation of MYR33-4A, MYR122, and 155 in LSD-M patient compared with healthy control. The expression level of MYR27A and 3378 was significantly elevated only in patient 2 who present hepatosteatosis and diabetes. In conclusion, a significant increase of MyomiRNA expression level was detected in serum of NLSD-M patient, and it is due to a muscle damage of their involvement in lipolytic way. Muscle MRI CT scan demonstrate that muscle mass correlate with MYR206 level. A marked elevation of some MYRNA involved in lipid metabolism was observed in serum of our patient. In particular, MYR33A that play a key role in the inhibition of expression Browning gene in obesity and in hepatosteatosis, and MYR122, a critical regulator of cholesterol and liver, are strongly upregulated. Increase of these mRNA are correlated with high level of hepatic enzymes. MYR27A and MYR370A was elevated OLMP2, who present hepatosteatosis and diabetes, and non-muscle symptoms. And this regulation of MyomiRNA and lipid mRNA may be an indicator, a biomarkers of skeletal and hepatic involvement, and might provide a tool to monitor the progression of NLSD-M. I would like to thank my group, Professor Angelini, and my colleagues Roberta Marozzo, and the groups of Professoressa Tavian with Sara Missaglia.
Okay, Valentina, thank you very much. Excellent. Questions? I don't know if Daniela Tavian want to ask any question regarding the role.
I have a comment eventually.
Okay, comment by Ugo, and then Daniela prepares a question.
No, start with Daniela.
Daniela first.
Valentina?
Sì, yes.
Okay. What do you think about these different genetic profiles of MyomiRNA? I thought the 3 patients has the same genetic basis, the same mutations.
Good question.
I think that this mRNA, this pathology is regulated, is more factor that regulate these pathologies. This mRNA could be aid to explain some things and to follow the clinical scene of the pathologies.
Okay, Ugo.
Are these very...
Microphone.
Simona?
Simona.
No.
Microphone. Microphone.
Microphone.
Sorry, can...
Ugo, microphone.
Mike?
Non sono io stavolta. Non tocco più.
Are those that molecules very labile, fragile, or are resistant?
microRNA.
Sorry?
Circulating microRNAs is very resistant in serum.
It
in
is
serum
very
plasma.
resistant. Very
Yes.
If they are very resistant, would you make a present to Ugo to test next time also saliva?
Yes, or plasma.
Thank you very
serum.
much. That's all.
Thanks.